Okay, so if you go back to the list of notebooks, there's one called Chile 2010 Tsunami, and that's the one I'm going to go through. I'm actually going to quickly run all the cells, simply because some of the later cells take a while to render, and if we're all trying to do it at once, it might slow things down. Also, we're kind of running out of time. We've got more material here than we can cover probably, so I'm going to skip over a lot of the beginning of this notebook. Part of it is just more about plotting and some projections. So here I've read in topography data for off the coast of Chile in South America. There was a tsunami that originated there in 2010. And what's different about the data we're going to look at this time is that it's not just sort of the maximum flooding depth over all time. Instead, it's actual time frames of data as the tsunami is propagating. And here I've loaded in data for something like 10 different times, going up to 5.5 hours after the earthquake. And the data is all in this same repository, so you can play around with it. If we read in one frame of the data, then we get a plot which isn't very nice, but if we mess around with it using some of the tools we were talking about before, we can get a plot that looks like this maybe, where the turquoise is the sea level, red is elevation above sea level, blue is elevation below sea level, so we can see the tsunami about 4.5 hours after the earthquake has propagated out about this far. And then to make things more interesting, in this case I've decided to project things onto the sphere, and in this notebook I'm not using Cartopy, I'm using BaseMap, which is sort of an older version, it's kind of built into Matplotlib, although it has to be installed separately. Cartopy is supposedly replacing BaseMap, so it should be possible to do what I've done here in Cartopy, although Tony and I were having trouble getting the sphere to come out looking quite right, so I just kept the examples from last year using BaseMap. So I'm not going to go through what we did here at all, but the idea is that we can get a projection onto the sphere, and we can plot this data onto that projection. So here's that same data we were looking at a moment ago, but now projected onto the sphere. And of course, I only had simulation data over this region that's colored turquoise here. So what I really wanted to talk about in a few minutes here is how we can animate this, because we could now read in a different time frame and see the tsunami at a different time, but what we'd really like is an animation of how it propagates. Well, here I've written a little loop that just reads in 4 different frames at 0, 4, and 8 hours, and does the same sort of plot for each one. And so what that will give you when you run this, it calls this figure function 3 different times, once each time through the loop, and so it creates 3 figures as output. We see it at 0 hours, at 2 hours, and at 4 hours. But that's not exactly what we'd like to see. We'd like to see an animation of how it evolves. So there's a little module in this same directory called animationtools.py, which you can take a look at. I won't go through it. This is kind of hiding behind the hood a couple of different ways of animating figures that you make with Matplotlib, or any other way that you want to make figures. You can take a set of images and animate them in various ways. So I'm going to just kind of quickly show you what comes out of this, and then if you're interested in learning about this, you can take a look at that module to sort of see how things are really implemented. So what I've done here is to define an empty list, figs, open close bracket just defines a list with nothing in it, and then I've got a loop over all of the frames. In this case, I guess there were 12 frames, so I'm looping over all of the frames. I'm producing the sort of plot that we just looked at, and after I've created that fig, the figure was created here, I'm appending this figure to my list of figures. So in Python, a list can be a list of any sort of objects. So it can be a list of figures, for example. And then after I've appended it, I'm closing it so it doesn't actually show up on the screen. So when you execute the cell, nothing appears as the output, but it's done this, and it's now created a list of figures. If I just typed figs, we would see it is a list of 12 figures. And now there are various ways you can animate this. And again, this is sort of hidden under the hood within this animation tools module, how we're doing it. But the first way I'm illustrating here is there's a whole set of tools for the Jupyter notebooks called IOWidgets, various different widgets that you can use to make plots interactive. And so the widget that's being used here is simply a widget that produces this slider bar, which can be used to adjust the frame. And what's happening under the hood as you move this slider bar is it's calling a function that's just displaying one of these 12 figures, depending on the location of the slider bar. Okay, so that's one simple way. And there's a whole range of different widgets that can be used in Jupyter notebooks. You can have drop-down menus, you can have slider bars of various different types, and it's kind of a very useful tool for making interactive GUIs essentially in the notebook for people to explore your data. So it's worth learning about IOWidgets if you don't know about those. And then another way that's handy for other applications is to use a little package called JS Animation, which is something that Jake Vanderplas, who's a data scientist here in the eScience Institute, put together that just takes a set of images and wraps it with some JavaScript in a way that you can view it as an HTML page with some controls. But you can also view it in a notebook. So again, look in this animation tools module if you want to see how that's actually called here. But we provided this little JS Animate Images function in that module, which takes a set of images and renders them as a movie or an animation within the notebook. So you can play it, you can speed it up or slow it down, do various things with it. Yeah, so in order to do that, I actually took this list of figures and I first converted each figure, each matplotlib figure, into an image, like a PNG file, only sort of an internal representation. And you can specify how many dots per inch to control sort of how good the resolution looks. And then from that list of images, this little function converts it into this sort of animation. One nice thing about this relative to the widget up here, this widget only works if you're actually running the notebook. If I store this notebook on GitHub or on my web page and I point someone to it through NB Viewer, for example, or if you just open it in GitHub and look at the rendered version of the notebook, the widget doesn't work. On the other hand, the JS animation does work if you view it through NB Viewer, for example. So you can put things up on the web that people can look at, and as they're reading through your notebook, even though they can't execute the cells, they can be seeing the animations you've created. There's also a little function in there that creates a standalone HTML file so that rather than having to open the notebook to see it, you can specify an HTML file and create a standalone page that has basically the same animation in it, which is just an HTML file now with the JavaScript embedded that you can post anywhere you want. Okay, so that's basically all I wanted to say. This is just another example